Our solar system has two planes of orbital alignment. This is what a radical new discovery suggests. We always thought that there was one plane. Well, there isn't. There are two. And if you could look at the solar system for distance, you'd see that the illustrations have at least one thing right. The planets are more or less aligned on a flat plane circling the sun's equator. This is called the ecliptic, and is thought to be a remnant of how the solar system formed. A flattish disk of dust rolling around the sun, gradually clumping together to planets, asteroids, and other chunks of celestial rocks. Kindly support my Patreon account because YouTube has again demonetized my channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. But there are a few bodies that move around outside this plane, mainly long-period comets with orbits of hundreds to tens of thousands of years, orbiting at the farthest reaches of our solar system in the Oort cloud of icy bodies. We might understand their strange orbit now. According to a new research, some of these long-period comets seem to align along a different orbital plane, what its discoverers are calling the empty ecliptic, rotated 180 degrees in respect to the galactic pole. The finding could shed new light on how comets originally formed in our solar system. We can't actually observe the entire orbits of long-period comets. They're small, they're dim, and we simply don't have the technology today to see them past a certain point, not to mention that their orbits are much longer than a human lifetime. But when they actually observe the entire orbits of long-period comets, they're small and dim, and we simply don't have the technology to see them. But when they get close enough to the sun for us to detect, we can use their trajectories and velocities to infer their entire orbits. Astronomer Eureka from the University of Occupational and Environmental Health and the National Astronomical Observatory of Japan and her colleagues have been working to calculate the orbits of long-period comets for some time, and in doing so, they noticed something very interesting about the point in the orbits farthest from our sun. She explains that this point is called the aphelion. That means it's from how far it is from the sun, and it should remain pretty close to the ecliptic for bodies whose orbits originate on that plane. For some of the long-period comets, that was the case. But there was a second group of long-period comets for which the projections did not indicate an aphelion consistent with the ecliptic. But nor were their aphelions randomly distributed. Instead, they seemed to align along a second, otherwise unpopulated orbital plane. The ecliptic is oriented 60 degrees in respect to the galactic plane. The new empty ecliptic is also oriented 60 degrees from the galactic plane, but in the other direction, and that could be a clue as to how the empty ecliptic came into existence. It could have been generated, the researchers say, by the galactic tide, that is, a gravitational field of the galaxy itself. Over time, this could have pulled some of the long-period comets askew. That's why the team called the second ecliptic empty, quote-unquote. It initially started that way until, over billions of years, the galactic tide populated it with comets. This is not an unknown concept. Astronomers have been predicting an effect on Oort cloud comets by the galactic tides for decades, and still it's an idea that needs more evidence to support it. So Higuchi and her team performed analytical computations to model how the galactic tide would influence these long-period comets. And just as she predicted, the distribution of the aphelions had two distinct peaks, near the ecliptic and the empty ecliptic. It's a very strong piece of evidence, but there's more work to be done to confirm her findings. Higuchi said the sharp peaks are not exactly at the ecliptic or empty ecliptic planes, but near them. An investigation of the distribution of observed small bodies has to include many factors. Detailed examination of the distribution of long-period comets will be our future work, she says. This research was published in the Astronomical Journal and it's by Michelle Starr on Science Alert. Please leave your comments. Thank you.